In this video, I'm going to provide an overview of the Python content that was covered, starting from the topic function. I mentioned that function is a group of a statement that exists within a larger program. Essentially, function will help us have an input, do some processing, and produce an output, and we can put all of that within a black box where that black box can help us provide a modularized program. So we can actually assign that box to someone to program, and then we can define these modules and put them together in order to run, let's say, a larger program. So benefits of modularizing a program using Python functions is we're dealing with simpler code. We will have code reuse, and we will have better testing and debugging because we can test each of those modules individually. It leads to faster development because a bigger program can be reassigned, and it's better for teamwork. Again, we have a bunch of people working on different modules, and in the end we can put them together in order to run a major function. The most simple type of functions were void functions, which will simply execute a statement and it will essentially return whatever that's within that program. But also we have functions that are, a simple void function would be defining a function using def that just prints a statement. Let's say def hello, and then within that we say print hello world. So it will just simply do an action without having to be dealing with any other input or output that's not related to that function. We also have value returning function. These are functions that receive a value and return a statement based on what they are. A simple example would be when we use an input function or an integer function or string function or a float function. They receive a value and they return a value based on what they are. For instance, if we provide a float value to an integer function, the output of that is going to be an integer value. Let's say if we say integer of 3.5, the output of that is going to be value 3. These are examples of built-in functions. Some of them we have covered in this course. Some of them are for you to explore. Example of things we learned were frozen set, len function. We have dict, which will turn values into dictionary. We had input, integer, len, print, range, round, set function. We learned tuple. We learned how to slice. We sorted values, minimum, maximum, string function, type, and the like. And we talked about zip, I believe, at some point. But the most important type of function, the reason why we learn functions is to be able to provide user-defined void functions. User-defined functions are the ones we create using a def as a syntax. They can be void or value returning. A void function is the function that, again, just does a simple statement without returning any value. The name is usually descriptive. The function header, which is that part, is the first line of code, which has a keyword def, and then in the end is all the statement. We call it the block or the set of statements that belong to that function. We can also have a main function. We commonly use a main function anytime we're dealing with modularized program, and main function is the function that calls all the other functions, essentially each of them referring to a module. We can think of this as the manager, as boss, and puppet master. So all tasks are delegated to functions, and then all of them can be called on once we call the main function. It's the we usually call, we don't give it any name, and we call it main, which is going to be called in the end. This is an example of, let's say, a simple function. The first one essentially has a message. We'll say define message, just print some statements. And then once we do that, our main function is to call the message function. So we say, I have a message for you, print these statements, and goodbye. And this is an example of an output. So it will print the statement that comes before calling the function, anything that's within that function, and whatever that's after that function is called. I'm not going to go through the logic, but we have an example that's coming shortly after. I will review that shortly. So designing a program, in order to create these modules, we commonly use a top-down design, which is a technique for breaking down algorithm into functions through a technique called decomposition, which is where when we have tasks and we form a hierarchy chart where we have each of these items, and then through hierarchy we show that the relationship between the functions, the sub-functions, and the main function. So essentially each box refers to set of codes or line of programs that are contained within a function. And we also have value returning function. Most likely the functions we design are going to have a value that's being returned. In order to use a value returning function, we need to have a statement called return, and then we mention what's the value that is being returned. So it could be one value, it could be multiple values, in the same way that we can have one or multiple inputs. So for instance, our value returning function could return a string. In this simple example, we receive usernames through an input. We say once we have the name, we store it in a function, in a variable called name, and then we return that value. So we return name. So essentially, this can be thought of as blocks that provides a string assigned to a variable called name. It can also have multiple values. We mentioned this. Let me go forward. So multiple values. So we also can have multiple return values. And when you call such function, we can think of it as separate values coming out separated by comma. So those, in the same way that we return, we can also reassign them and reuse them, let's say in another function, if that's something that we need to use. This also includes passing data into the function. So essentially we have piece of data that's sent into a function, and function then can use that argument in order to do certain processing, whatever that's related to that function. And here parameter is essentially the local variable that receives the argument, and we need to think of the scope of the parameter, so where that function is going to be used. This is an example of passing data. Let's say function A receives 3 values or has 3 values stored. These could have been also input from the user. The output of that is going to be 3 variables, so it's returning name, country, and city. And in function B, we are reassigning these values with receiving them from function A. So 3 values are coming from here and being reassigned to my name, my country, and my city, which are variables that are within the boundaries of function B, and then we can do something with them. In this case, we're only printing them. So we say print these now reassigned values. And once we print function B, we will get all these 3 values printed. All right, so let's look at some examples. So in this simple example we have covered in class, we were talking about a function where we are computing salaries based on the base hour and base pay, and we also had some overtime. So in order to break this down into a modular program, we can define, let's say, 3 different sets of functions. Here I have a function that computes their salary, let's say their base pay. So here we knew that if the hours are over certain hours, let's say 40 hours, then we have overtime, and the rate for overtime was different. So we go through all of that. The output of computing pay is going to be salary or one variable called pay. Then we were worried about, let's say, taxes. We can use that, the values that are provided, let's say the hours. Also, in the same way that we used it in that function, we can use hours in order to calculate taxes. So we have the formula, we just do that, and then we return tax in this, or taxes in this statement, in this function. And our third block, our third function is, imagine we were calculating auto benefits. I'll say 5% of the base salary is going to be considered the benefits. So we calculate that. The outcome is going to be benefit. Now, once we have these statements, if I run this, there would be no output, but all these values are going to be calculated. Now I'm defining main. Here I'm getting my hours, and I'm assigning it to a variable. And once I have the hours, then I can use compute pay. I can call it from up there and give the number here in order to get the base salary. I can do the same to calculate, let's say, the net pay, which would be the salary minus the taxes plus the benefits. And then we can print each of these statements. All right. Now, if I'm calling main, so you have to call main. So main is defined based on these 3 values. And now I'm calling main. Let me just print each of these. So that's running and that's running. And now I'm calling main. Let's say this is the hours I worked, and you will get the answer for each of them specifically. Next, we covered list and tuples in Python. We mentioned that list is a collection of values that are contained within an object. These items can be string value, number, or they could be a Boolean value. They could also be, each of them, another list. And list is characterized by values coming within brackets. We can create a list using also a list function. So elements of the list can be are immutable, and they have an index, so the order matters in list. These are examples of different lists that we can create. We have commas between values. We talked about indexing, so the first value is going to be 0, and the last value always going to be -1, in the same way that, for instance, we worked out the string values. The len function will give us the size. We talked about enumerating function. Enumerating helps return each of the values within an object, and that can be useful anytime we're running, let's say, an iterative loop and we want to convert those values into a new list. We can use enumerating. We can also use copying. We can copy the values within a list, but enumerate will return values one by one. It's also possible to do slicing using the start-stop index. The last element is optional, and we can also mention the step. Let's say every other value. If that's something we have in mind, we set the step to 2. We have several examples in class. We can also use in and not in function operators to check if the value exists within a list or not, and the output of that is going to be true or false. We went over some of the common methods that apply to list. Again, a reminder that lists are mutable, so we can append an item, add an item. We can index, return the index of an item we're looking for. We can insert a value based on the index, which is different from appending, which will add the value to the end. We can sort the items. We can remove the items. We can also reverse the values within a list, basically changing the order. Again, order matters in the list. We talked about list comprehension, which is when we are using a for loop to go through every value. Instead of running a for loop like this, we just say the syntax for it is the value for value in the original list, and if we have a specific, let's say, criteria, we can specify it. Otherwise, we can just create a new list using that list comprehension again. And for processing lists, we use usually a for loop. And for instance, if we want to calculate the total number of numeric values, we can run a for loop using an aggregator. We can also use the sum function. If we're looking for average, we can calculate the sum and then divide it by the length, which is the total number of values in a list. We can also have two-dimensional lists. Two-dimensional lists, we didn't work with them much, but if you work further with other packages in Python, such as NumPy, two-dimensional lists are very useful. These are examples of, for instance, if we have a list of grades for different students in class. So we have a bunch of lists in 2 dimensions. But we can use them, again, we can index them very similar to the way we index a one-dimensional list. So the first value in the first row, first column is 0, 0. And then we can follow that in order to capture each of the values, or if you're running a for loop. I also covered tuples, very similar to lists, with the difference that they are immutable. So lists, we can change the values. In tuple, we cannot change the values. Tuples are better for if we're looking to, let's say, secure some values, if we know that we're not going to change them over time, if we're looking, for instance, some keys. So anything that's how processing values in a tuple, all those methods will work. But if we're looking to change them, let's say if we want to insert or append, we will get an error for tuple. So appending, removing, inserting, reversing, sorting is not going to be supported because each of those are going to change the values in a tuple. Let's run some examples. So we have example of creating a simple list, 1, 2, 3, and we can add it to an empty list using concatenation. Now we have a new list called MyList with these values. We can append or insert. In this one, I'm inserting. So if I'm running, the original list is now extended with the value that came at the end. We can pop values and assign them to a variable. Let's say here, the last value, the value that's in index 3 is popped and assigned to variable y, which was 40. We can also delete a range of values. So in this example, I'm just deleting range of values. So our list is shortened. And this is an example of comprehension. So we have the value. In this case, we want to change the values that are in a list of numbers by the range of 5. So 0 to 4. I want to turn them into by the power of 2. So if I'm creating this list, I have 0 to 4, again converted to the power of 2. So we have 0, 1, 4, 9, and 16. And if we're looking for additional clauses, we could just add them here. This was an example of enumerate. Let's say we want to enumerate through a list, get each value, and again return those values. Basically convert each value of an index 0 to the end of the list, convert each value to the power of 2. So we're looking for a list that has let's say 100, 400, all the way. So we're getting each value. This was printing here. So if I'm turning that into a comment, we see that we have 100, 400, all the way. And tuple, very similar to list. The only difference is that they are not mutable. So this is an example of how we can create values within parentheses. And if we run any of the methods, we will receive an error because we cannot modify values that are stored in a tuple. Next, we covered the topic of strings. In strings, we were interested to see what are the things we can do with a string within a Python program. We talked about embedding special characters that will help us create a horizontal tab or new line. So /n and t, which can also be treated as commands when they're embedded in a string. So if we have those values in a string, that's not going to be considered a string. If I'm running a len function, all of that together is considered one character. We can also use plus operator in order to concatenate two strings. We covered indexing and traversing. I'll talk about traversing, but indexing starts with 0 for any string. So the first character is always 0 all the way to n-1, whatever the length of that string is. We can also calculate backward starting from the end, which is considered -1. We can use indexing in order to create a loop. We can, let's say, for character in the string, go through and let's say count them or turn them into upper or lower character, do whatever you want with them. So it will traverse and it will go over each. We use len function to calculate the length of a string, and we can also be careful because if we are using any character, if we're calling a character from a string that's outside of the length, we will get an index error. These are examples of dealing with the strings. We said the strings are immutable, means that the strings can be reassigned and changed within a variable. For instance, we can have a variable and that value can be updated and changed. So that was similar to lists and also dictionaries. These are examples of a slicing. You can use range in order to take part of a string out. So let's say if I'm saying 0 to 4, I'll get this part of this string. If I'm counting backward, I can do the same. You can also use a step. So if you had 3 values, you can also step and let's say collect every other character from whatever that's stored in a string. And we can use in and not in order to see if a word exists, let's say in a sentence or in a string. So it will essentially if the string 1 is a substitute of a string 2, the outcome of that is going to be a true value, a Boolean value, otherwise it's going to be false. And if you use not in, that will be reverse. I also covered some of the things we can do with the string values. For instance, we can use is alnom. It stands for if the value that's in the string is alphanumeric or just alphabet. If we were interested to check if all the values are only digits, we can check that. Let's say we can test this, and if the output of that is true, then we can turn it into an integer using an int function. We can check if there are lowercase or uppercase, if there's any space in it. All of that are examples of some of the methods that are available when we're using a string. And we also had a strip which will return a copy of the string with all the white space character removed. We can use other examples. You can try to run a strip, for instance, return a copy of the string with all the leading and trailing white space characters removed, so no space at the beginning or an end. And we talked about upper and lower. So again, feel free to practice on those with the examples we covered in class. And also there are some examples to check for substring. Let's say we can check if a string starts with certain characters, or if we're looking to find something. We had an example of checking emails, which I will review again here. Or if you want to replace an old string with a new string, we can use these methods that are available for string. We can also split a string using a split argument, which will return a list that contains all the words that exist in that string, and it will use a space as a separator. If we pass an argument through a split, it will use that argument as a reference point, and it will split our string based on the value that's provided here. Alright, so let's go through some examples. So imagine we have a string, I have a bunch of digits here, and I want to calculate the total sum of the integer values that are here. So I mentioned strings can be traversed, so we'll run a for loop, and we have count 0, total 0, and here every time we go through a character, we add it to the total by turning those characters into an integer. I could have also checked is digit for each of the characters. If you were running that, you will get value true for each. And then we count them also every time we go through the loop. So if I'm printing this, it will tell me it has 14 digits, and the total count for these characters are coming down to 31. Another example was if we have a string and we want to slice it up, we can say start from 5, let's say to 0 to 5, and then with a step of 2. And then once we print that, we'll get every other character starting from M stopping at index 5, which is the space. We talked about split. So if we're splitting without any argument, so if there's is void, the function will return a list of all the values based on the white space between them. So we have every character in a list, every word in a list. If I'm passing an argument, it will split that sentence or that string using the reference that we have provided. So it will split based on that word. So now we have two strings. Fun is not in it, and that's assigned to a new list. Another example would be when we use these methods in order to, let's say, find a specific thing in our data set. So here I passed a long string, let's say just an email I received from someone, to a variable called email, and then we define @ at the position where we can find the value of @, and our goal was to capture the domain name. That's what we're trying to do. So first we capture the position for this, and then we find the position of the space starting to look from this. So we're essentially looking at the space after that. So we say space is equal to email find. We're looking for space and it's starting from @ position, whatever that position is. And next we can say our domain email is from @ to this space. So if I'm printing that, we see that this space, so first this is the character 47, and then from here we capture domain email starting from here. I could have said, let's say here I can say 47 was actually @ was a space, so I can say print @ position. So we're capturing essentially between index 31 and 47 from that string. And then we have that. And if I wanted to see, for instance, who is this email from, I can say print everything all the way to @. So these are examples of some of the methods we can do in string. Another topic that we reviewed in class were related to dictionaries and sets. I mentioned that dictionaries are objects that store a collection of data based on the relationship between a key and a value, so they're pairing them up. Example of dictionary would be when we have multiple values that sorted as a pair within curly brackets. You can also create a dictionary using dict function within parentheses. Dictionaries are very fast, the keys are mutable, objects and values can be of any type. Keys can be any value, but they need to be unique because they're being used in order to retrieve their values. And keys and values can be of different data types. These are information I just mentioned, so we can use curly brackets or DICT function, and we can pair up the values as we're creating them. We can also retrieve values by calling the key. So because lists don't have indexes, we can only use keys, and if the key is not found, we will receive a key error. We can use in and not in operators in the same way that we used it previously in order to test whether a key is in dictionary, and that would be helpful to prevent key error. And another method which is better in order to avoid getting a key error is using the get method. The get method will help us receive the key, and if the key doesn't exist, it will return a value or the default value that we specify. We can loop through a dictionary by using a for loop. So dictionaries are iterable. They do preserve the order of insertion. So when we're running a for loop, it's based on the way they're inserted. We can use keys method and values in order to return the values and keys that exist in the dictionary. Next, we can use items. Items will return a combination of dictionary keys associated with their values. So they're good if we need to loop through both. So we're basically the sequence, each of them is going to be a tuple, which includes the pair, and it can use a variable which receives a tuple, or can use two variables which retrieves key and value. So DT items can receive one or two. Some of the methods that are available through dictionary, we can delete values using the key. We can pop using the key and also the default value. If the key is not found, we can pop an item which will return a randomly selected key value pair. We have clear to delete all the elements in our list, and there's also a bunch of others that we covered in class. We can see an overview of them in this table. In the dictionary method, we can also pass values. We can say key is equal to value, so a combination of those. We can also convert a two-dimensional list into a dictionary. We talked about them in lists, which is a slightly harder method, but we can turn a two-dimensional list into a zip and then read that value as an input to dictionary function. So let's run some examples in Notebook. So we can create a dictionary either using curly bracket and pair of keys or DICT function. So here I can just print and we'll get the values. If I'm interested to run a specific value, I can just assign a key, January, and I will get the value out. We can use a for loop in order to iterate through each of these items. We can pair, we can receive both values, the pair, using DT items. This should be DT sales. So when I'm doing that, I will receive all the values. If I was interested to only getting the keys, I can just say key in DT sale, and also you could say DT sales dot values in order to use that. We can also use list comprehension in order to create some values. Here I am simply using a reverse statement, so I'm receiving K and V from DT sales, and I'm writing that into value and key, so we're swapping the values. So we'll receive the list. with reverse values. This was also an example where we could count the characters in a statement. Using a for loop, we will create the letter, and also we will increase the count anytime that letter is repeated. So if I'm running this, I will get the count of all the values. If I wanted to, let's say, get rid of some characters, you can use other methods that I have covered in class. And again, that would be a good way to be able to get all the values out. Next to dictionary, we also talked about set, which is an object that stores a collection. This also comes in curly bracket, but it's only one value. So all items must be unique. So we can think of them as only keys in dictionary. It is unordered, there's no indexing, and elements can be of different types. And it's a useful method to think about the mathematical set, like what is shared between two lists, between two sets, or what's set 1 minus set 2. So in order to create it, we use a set function. We can pass an argument. Those arguments can be iterable elements, so we can use comprehension in the same way that we do for list. We can create sets like that. We have len function, adding method, updating method. In order to add a group of elements, we can remove and discard. The difference is discard will not raise a key error, so if the value doesn't exist, it will not give us that error. We can use clear to clear all the elements in a list, and we can use a for loop in order to operate between these values. We also can use in and not in the same way that was useful for other objects, data objects we knew. But what's unique about set is that we can actually calculate 3 unique things. One is the union of two sets. Let's say you can say set 1 union of set 2, or you can use this operator. We can also use the intersection of two sets. So we say set 1 intersection of set 2, or set 1 and set 2, which is the value that's shared. And also we can have the difference, which is set 1 difference set 2, or set 1 minus set 2. And these could be very useful in certain use cases. Let's also see some examples of set. So we can create a set by passing an argument to a list. So I have a list and I'm using set function to create that. So we see that the values turn into curly brackets and there's no repetition, so number 3 is removed. Imagine we have 3 sets, set 1, 2, and 3 with different values. We can calculate the union, the intersection, and the difference of these using the methods that are available to set. So let me just print these. So we get those values out. I could have also used these operators. So this is union. So I'm unioning set 1, 2, and 3. The results are the same. We can also look at the intersection of all 3 sets. And also if we were looking at the difference of set 3, 4, and 5. So this is set 3 minus set 2 minus set 1. In this course, we also covered how to access and work with files in Python. So file is an example of an object which contains data, information, configuration, settings, commands, or numbers, and it can be stored on the computer or any other hardware, and then it can be retrieved within our Jupyter Notebook or any other compiler we're using. So in general, there are 2 types of file that we learn how to work with. Most likely we're dealing with text files. It could be also files that are binary and can be converted to text. General functions that we learned was opening, reading data, writing data, be able to get the output from our text file, and also be able to append to it. There are also other files and extensions that can be retrieved within Jupyter Notebook, although the easiest one in order to process is going to be txt or text file, where it contains values that are stored as strings. In order to open the file, there are different methods. The most common one is using the open. We have the file name in addition to the directory, and the mode that can be reading, writing, and appending. If the file is located somewhere that is different from where we are running our notebook, we need to also provide the path to the file before the file name, and then mention the mode. We also add R before the path name, indicating that the file is a raw string if that's the case. For writing, we can use W, and we can use the file variable name .write, and then pass the string function, and it will overwrite to the file. So if the file doesn't exist, it will create it. If the file exists on our hardware, it will overwrite the file. And we usually need to close the file once our job is done. We don't want to leave the files open. Appending can be done using A as the mode, and what appending does, it will add data to the end of the current content, but if the file doesn't exist, it will create that file on our computer as well. There are some functions and there are some methods that are available when we are opening a text file. We can use read, and it will read the entire file from the memory, and it will consider it as one full string. So it's one long string that includes all the content. We can use read line, which will go through the string line by line, including the /n that signifies the end of each line. We can also use read line within the context of a loop where we are retrieving information. Usually we don't know the number of, let's say, items or number of lines, and using a for loop, it will help us to be able to run a counter into the file and be able to get those out. We had several examples that showed how the logic works. So this is a logic for detecting end of the file. We say open the file, read the line, and did read line return an empty string? If not, you process it and then use the read line again until the response to that becomes yes or true, and then that will close the file. Here's an example of using for loop to read lines. So Python allows programmers to write a for loop that automatically reads line. And this is more elegant way of printing the content, and the loop will iterate once over every line. If the values in our file are numbers and we want to retrieve them and do some sort of processing to them, first we need to turn them into an integer. So we had two different converters. Let's say if the value is needs to be converted to integer, we can use int. We can also use float function to convert these values. But again, depending on what we want to do with the content of the file, we can use these different converters. So let's run some examples. We can open the file using an open statement, or we can use with this structure. I can say with open and then do read line, so it will go through the file and it will read every line, and we see that signifies that these values are in different lines. And this is another example where we are opening a file courses and we want to write some values into it. So once I run this code, so we say open, the mode is going to be writing. We write some content using the variable name fob.write, and then we are closing the file. So if I'm opening the file on my computer, these values must have been written to it. So let me try here. So all of those values exist in a file. And note that if we wanted the values to be written in different lines, we needed to use these characters. We can also use readline, and here we're doing strip, and readline will read each of the lines at a time, and our strip will essentially strip any white spaces from those lines. These are examples of when we want to count the number of lines in a code. So we can say read the files, and every time you go through a line, do a counter. So if I'm running this, it will give me that this file has over 4,000 lines. And again, these are different things you can do with file objects.